today we are going to introduce a concept very similar to what we did yesterday, but instead of using an equal sign, we're going to be using what are called inequality signs. So yesterday, the steps we used can be reapplied today. The only difference is when we get all the way down to our final answer, instead of getting something like x equals 5, we're going to get an answer that says x is greater than 5. So it's still going to feel like we get one value, but if you think about that, any number you can consider that's greater than 5 would technically be considered a solution. So technically, inequalities are different in the sense that there are actually infinitely many solutions, so long as they meet the condition that you find at the very end through this solving process. One other difference we're going to throw in is a lot of the times inequalities are usually represented on a number line through a process of graphing. And for that, I'm going to give you kind of a little chart that's going to help you recognize each of the inequality signs, as well as how they translate on the graph themselves. What I do want to draw your attention to, though, real quick, is that these 4 steps are almost an exact copy of yesterday's notes, with one exception. In step 4, there is a warning that says that dividing or multiplying both sides by a negative value causes our inequality sign to flip. Hopefully that doesn't shock us too much, because anytime we multiply or divide by a negative, it usually switches the sign of the value to begin with. It's also going to switch the sign that's between the two sides. So I'm not going to spend really a whole lot of extra time on those first 4 steps, because that's the exact same thing. Hopefully you spent time practicing yesterday. A lot of the same tricks we used yesterday are going to be applied today. But like I said, the key difference is going to be, instead of an equal sign kind of being our guideline, it's going to be one of the 4 inequality signs that I'm going to introduce to you now. So I pretty much summarized what's in that little paragraph there. So we're going to jump into this little table. I'm going to start with these first 2. They're kind of similar. One says that you're saying something is greater than, whereas the other one is greater than or equal to. So the greater than looks like an arrowhead pointing to the right. That is a greater than symbol. Whereas alternatively, is greater than or equal to looks very similar with an arrow pointing to the right, but the equal to part, it actually has half of an equal sign sitting underneath. So it's got the greater than portion, but it also has the equal to portion. And that's the key difference between those 2 signs. Now, in terms of the graphing portion, if you were graphing the greater than scenario, what you would use is what's called an open circle. And you would shade to the right. Now, visually, that would look something like this. An open circle at whatever value you end up with through this process, and then you'll include everything to the right of it. Because if you think of a traditional number line, the further right you go, the larger the values become. Alternatively, the further left you go, the smaller the values become. Now, as for the is greater than or equal to symbol, very, very similar, except the difference is that the equal to part says you're also going to include where you start. And visibly, the way we represent that is that we use a closed circle, but we're still going to shade to the right, because the right is where the numbers become greater. I say closed circle, that's typically how it's described, but for most people, usually they also describe it as a filled in circle or a shaded circle. But everything would still be included to the right. So those are our first 2 inequality signs. Second 2 as you may suspect, are literally the exact opposite. So less than is pointing to the left. Less than or equal to is also pointing to the left with that half of an equal sign sitting underneath of it. Is less than is going to be another open circle, similar to greater than, but this time we're going to shade to the left. Is less than or equal to will be a closed circle, still shading to the left. If I zoom out here, I think I can fit it all in the same. There we go. Those are the only 4 possible inequality signs out there. So it's going to be one of these 4. Good news is, anytime that I ever test you on something like this, I'll give you a little mini chart that serves as a reminder. I'm less interested in whether or not you can memorize these. I'm more interested that you can recognize what they are, what they mean, what you can do with them. In terms of which one is which, if I forgot, I would Google it. And as soon as I saw the signs and reminded myself which one does or stands for which representation, I would run with it. So again, I'm not interested in memorization. I'm more interested in utilization. Now, there is one caveat. This table will only be true if we stick with one of the habits we've kind of established, or hopefully established over the past couple of days, and that is that our final solution should have the variable written first. So that was something when we were solving the equations the past couple of days, when we got to the very end, if our equal sign, if our variable was on the right of our equal sign, we switched it around so the variable came first. That's going to be equally or especially important today. So a little note here underneath this table that says this table is only true if the solution is written with the variable first. So the table only works if your variable comes first in your final solution. Now, where it's at along that process, we don't worry too much. We sort that out through our other steps. But at the very end, make sure it's written first. And we should have a couple of examples where we'll make an adjustment there for those. One other thing I would mention about the table, if you are interested in trying to memorize which one is which, it's actually pretty handy. So long as you are always writing your variable first, the direction in which the inequality sign is pointing also happens to be the direction in which you need to shade. Again, that's assuming that you have the variable first, because if you have it flipped around, you're accidentally going to shade in the wrong direction. So long as your variable is written first, that trick. All right. So in my opinion, the best way to see these in action is to actually use them, to work through a problem where these inequality signs are in play. Hopefully it feels very similar to what you did yesterday on the practice. The only difference is we got to watch that sign carefully. As carefully as we watched our equal sign. So similar idea. Here we have an inequality. The only difference really is that instead of an equal sign, there's our inequality sign. Happens to be a greater than symbol. Let me guess about how much space I need there. Then I'm going to go right back into the steps that we kind of hit on a lot yesterday. All right, so we have our guideline in there. That's going to help us keep our inequality sign in place. Hopefully, what's the first thing that should catch your attention? Those parentheses. This time, what are we distributing? Distributing a 3 here on the left-hand side. So 3 times negative 2n is going to give me a negative 6n. 3 times 6 is going to give me 18. My greater than symbol drops down, my 4n drops down, and my negative 2 falls down. And that takes care of step 1. Step 2, what do we always check for next? Like terms. Do we have any like terms? What about the negative 6n and the 4n? They're on opposite sides. So by definition, they are not like terms. So step 2 doesn't necessarily apply here. Step 3, what do we consider? Getting the variable on one side, and that's especially important when it is on both sides. Now, technically, I usually suggest moving the smaller of the two, but we can also technically move either. Would you rather move the negative 6n or the 4n? Okay, how would you make the negative 6n disappear? Okay, so we're going to add 6n on the left. That makes it disappear there. But same thing with equations. We want our inequality to stay balanced as well. So we repeat that same process on the opposite side. You're welcome. Negative 6n plus 6n is 0, so it's gone, leaving me with just the 18. Bring down my greater than symbol. 4n plus 6n is going to give me 10n, and the negative 2 drops on down as well. So we took care of parentheses. There were no like terms. The variable was on both sides, but we fixed that. The last step is to get that variable by itself. Now, in this situation, what side is our variable on? It's on the right-hand side. That is the side I'm focused on then. So from that side, what are we going to start to take away? How would you do that? Add that to both sides. On the left, 18 plus 2 is going to give me a 20. Is greater than 10n. The negative 2 plus 2 is 0, which is gone. And then what's last to move? Where's the variable? That 10 needs to split off of that variable. It's currently being multiplied. So we do the opposite, which is division. So 20 divided by 10 is going to give me 2. Is greater than 10 divided by 10 simplifies to 1, which is why we're then able to hide it next to our variable. And I'm excited because my variable is now by itself. What's the catch? It's on the wrong side. If I were to try to graph it right now, I would try to shade to the right, which would technically be wrong, even though the symbol is a greater than symbol. But that table up above only works if our variable comes first. So here's the thing though, this is where it's a little bit different from equations as well. When we switch sides on equations, technically our equal sign was flipping. But when you flip an equal sign, what does it become? Does it change?
It's still an equal sign.
It's still an equal sign. So in that process on the equations, it didn't matter as much. But here, when I write my variable on the left-hand side, that inequality sign still wants to be pointing towards the same piece it was pointing towards before. So that greater than symbol is going to become a less than symbol. And the 2 is going to fall on the other side. And what we have now is our final solution. N, which represents all of my solutions, must be less than 2. And here's a number line for us to visually represent that same relationship. So where are we going to start our graph? At positive 2. Are we including it or not?
Yes.
Why? Well, it was a guess. Tabitha was shaking her head no, though. What was the sign, inequality sign we had here? At the very, very end. It's a less than. And however, it is not equal to, which means my set of solutions cannot include 2. N cannot equal 2. It has to be less than 2. So we can start right here at 2, but we use that open circle as the table suggested above to say, we may be starting here, but we're not including it in our list of solutions. And then which way do I shade? To the left. And hopefully it doesn't shock you, because any number in that direction, 1, 0, -1, all the fractions and decimals in between those values as well, all of those values are considered to be less than 2. 2 isn't less than 2, so we didn't include it. And then everything to the right is greater than 2, so that's excluded as well. And one other thing I should point out, it is important, although it seems trivial, make sure you're putting a little arrowhead there at the end, because does my number line stop? No, that number line says that these numbers do go on forever. So does my list of solutions. So -2, -3, -4, -5, so on, so forth, forever and ever and ever and ever, giving me an infinite list of solutions here. What do you think?
If you didn't have that arrow, would that mean it stopped right at the number the line stopped at?
Yes, so that would suggest that it is within a what's called a closed range, meaning it starts at one point and stops at another. The arrow says that it goes on forever.
Okay.
Yep. So ironically, when we get to the back side of our notes today, we're going to actually see some closed off ranges when we introduce compound inequalities. But first, we need to be comfortable with single inequalities before we get there. So again, hopefully, the steps feel very, very familiar, or at least familiar enough from yesterday that you can at least get down to the solution. What's going to be new is interpreting that inequality sign and then also considering the graph that goes along with it. And that's what today will be, spend time practicing those. But let's take a look at this second one here. Let me set up my guideline. I see a greater than or equal to symbol. So we want to make sure we keep track of that. But with that being said, what should catch our attention first? Parentheses. Yet again, you're going to get real tired of hearing me say that, but I'm going to keep saying it until you're saying it in your sleep. So on the right, we have a set of parentheses. This time we're distributing what appears to be a 5. I'm not ready to touch the left-hand side yet. No parentheses there. So I'll leave it be. On the right, however, 5 times 1 is going to give me 5. 5 times 5n is going to give me 25n. Took care of the first thing. What comes after parentheses? Like terms. Any like terms here? No. What may appear to be like terms, unfortunately, are on opposite sides, therefore aren't actually like terms. So then we consider our third case. Do we have a variable on both sides? Okay. Which one would you guys like to move? The 6n? How would you make that disappear from the left? Minus it. And whatever we do on one side, we have to make sure we do to the opposite side as well. So on the left, the 6n minus 6n will be gone. And all that leaves us with over there is that positive 5 that falls down. Greater than or equal to slides down as well. 5 on the right-hand side, we didn't mess with, comes down. And then we have 25n, take away 6n, which I believe gives us 19n. So took care of the parentheses. There were no like terms. The variable was on both sides, but we made an adjustment there. All that's left now is to get that variable by itself. Which side is it currently on? On the right side, so that's the side I'm looking at. So from the right-hand side, what are we going to start peeling away? The 5. So I'm going to subtract this 5 from the right. Whatever I do to one side, I have to do to the other. And for a moment, people are going to get a little worried here because yes, the 5 on the right becomes 0 and for our purposes disappears. But on the left, 5 minus 5 is still 0. But here's the thing, you can't just have an empty side. You have to have something there. So you really need to actually write in the 0 that's left. So I get 0 is greater than or equal to the 19n that's remaining on the right-hand side. 0 is a number 2. What's left to move? The 19 off of the n. How would you move that 19? Divide it from both sides. On the left, 0 divided by 19, still going to be 0. Greater than or equal to sign drops down. 19 divided by 19 simplifies to a positive 1, which we're allowed to hide. And I get that 0 is greater than or equal to n. But how would we rather write that? N is less than or equal to 0. Flip the whole thing around so that variable comes in front. So where's this graph going to start? At 0, open or close circle. Why closed? Because it's equal to. So it's included in my list of solutions. So 0 does equal 0. So I can include that. And which direction will we shade from there? To the left. We want everything that's less than 0 as well. Now, the notes today could have been significantly longer, and we could have done lots of single inequalities. That would have got, in my opinion, gotten really boring really quickly, especially since that's part of what the assignment is today. And most of it is just review from yesterday. So I figured, let's not do too many of these. Let's prove that they are very similar to equations before we introduce something that is a little bit more advanced. Still uses a lot of the same tricks we've learned already in just 2 days, but kicks it up a notch by kind of doubling the work we need to watch out for. So before we move on to that, any questions on just individual inequalities? Maybe not now, maybe when you come to the assignment. That's, again, one thing I should have pointed out yesterday on the assignments. If you're someone who's usually used to getting them right or worried that getting them wrong is a bad thing, I actually strongly encourage you to make mistakes on those. Don't worry about getting it right the first time. That's not going to be where you learn much of anything. Even if you guess right, you won't know why you're right. I'd rather you make the mistakes. I'd rather you struggle through it a little bit, because at the end, you're going to feel more confident in your ability to handle most math problems. But that aside, let's take a look at the new stuff. So this is where it gets a little bit more interesting. So next thing we're going to look at here is what I refer to as compound inequalities. So we did a couple of inequalities already, but now we're going to add this word compound to it, which basically just refers to us that there are two separate inequalities combined together in the same problem. So what that means for us essentially is, yes, we have double the work, but all we're going to really do is solve one of the inequalities all the way through, just like we did on the front, and then jump over to the second one and solve it all the way through. And we'll have two parts of the answer. At the very end, we then figure out what do those two parts mean together. Now, there are two types of compound inequalities. There are and inequalities, uses the word and there are or inequalities, which uses the word or. So compound inequalities, there are two types, and an or. Now, ironically, the English behind those words kind of plays a role here as well. Because if you think about what it means to say and versus or, it changes the outcome or the meaning of a sentence. And the silly example I like to give every term, so if you've had me before, I apologize, is if I were to ask you as your assignment for tomorrow, I want everyone to bring me a big blue teddy bear. And Harmony brings me a little tiny blue teddy bear. Will I be happy? Why not? Big and blue. So it had to be both, right? Both have to be true in that scenario. Now, if I go back and say, okay, never mind, let me change that assignment. And I change just one word. I change the word and to or. And I say, instead, tomorrow, I want everyone to bring me a big or blue teddy bear. And Toby, you bring me a big green teddy bear. Will I be happy then? Sure. I said big or blue. So it could be big and literally any color. I'll be happy because it was at least big. Or it can be blue and it can be any size because it has to at least be blue. So one or the other. So and means everything has to be true. Very, very particular. Or it's like, one or the other, I don't really care which, so long as at least one of them is in fact true. So with that in mind, and inequalities, in my opinion, because they are so picky, usually feel like the more challenging of the two compound inequalities, whereas the or inequalities, it's pretty cut and dry from start to finish. It's just these and inequalities are especially particular, and I'll show you why. So right off the bat, we're going to start with the harder of the two examples, or of the four examples, I should say, and that is these and inequalities. Now, typically, when you are presented with an and compound inequality, they're going to be written together, smushed together to appear like they're just one problem. And what we have to do first is actually split them into the two separate problems that are actually hiding there, and then solve them, and at the very end, slide them back together again. Now, let me ask you this. How do you, if I gave you no context right now, how would you know that there are two inequalities hiding in this problem? There's two symbols. There's two inequality symbols. I have a less than or equal to symbol here. I have a less than symbol there, which means that there's two comparisons being made. There are two inequalities hiding in this problem. Now, I use the word split up above, but there's a better word that describes how we break these two apart. So Toby, I like that you honed right in on those symbols, because what's between those two symbols is especially important. So in this case, we have a 3r minus 7 nestled between the two of them. And that 3r minus 7 is what we want to make sure we share between our two inequalities. I don't want to cut it in half, take the 3r on one side and the negative 7 on the other. I want to use the whole 3r minus 7 in both. So this is what that would look like. I always like to start from the left. I'm very routine in my method. So the first inequality will be 8 is less than or equal to 3r minus 7. I always like to write the word and, just so I remember that they were originally together. And then the second one is going to start with 3r minus 7, which is all going to be less than 17. So the 8 less than or equal to 3r minus 7 is right here on the left-hand side of my inequality. And then the 3r minus 7 is less than 17 is going to be on the right inequality. The 3r minus 7 should be completely in both, however. Now, aside from that minor adjustment, how we solve them hasn't changed in the slightest. Set up my little guidelines here because I do have two separate ones I'm going to solve, just one at a time. Don't be fancy. Don't try to do both at the same time. And then I'm going to start over here on the left. 8 less than or equal to 3r minus 7. Are there any parentheses? No. Any like terms? No. Variable on both sides? No. So all that's left is to get the variable by itself, right? So on this first inequality here, it appears to be on the right-hand side. What would you move off of the right-hand side? You're going to get that -7 out of the way by adding 7 to both sides. Eight plus 7 is going to give me 15. Is less than or equal to 3r because the -7 plus 7 is 0. Then what's left to move? The 3, because we're still just trying to get that variable by itself. So it's currently being multiplied with the r. We do the opposite, which is division. 15 divided by 3 is going to give me 5. Is less than or equal to the 3 divided by 3, which is 1, which we hide, leaving us with r. Now, the way it's written in that form right now is going to serve us later. But for our purposes, when we go to think about the graph here in just a moment, it may be worth also having it written where the variable comes first, just like we did on the front of our notes. So notice that not only do the two sides switch, so does the sign. It flips in that process. And that half now tells me that whatever my solutions are, they're going to have to be greater than or equal to 5. But that's only half the story. We still have a second inequality to solve. So I'm going to slide over there. Any parentheses? Nope, no parentheses on this side. Any like terms? No. Variable on both sides? No. So this one is pretty straightforward, just a two-step inequality. It's actually going to feel very similar to the last one. I'm working on getting that r by itself. It's on the left side this time. So I'm going to add 7 to both sides to get that -7 out of the way. Leaves me with a 3r is less than 17 plus 7, which I believe gives us 24. And then to break that 3 away from the r, it's currently being multiplied, so I do the opposite, which is division. 3 divided by 3 simplifies to 1, which I hide, which leaves me with r is less than 24 divided by 3, which gives me 8. So at the end of this, we're now being told that wherever our solutions are, they're going to have to be greater than or equal to 5. So hopefully you can sit there and already start thinking anything to the right of 5 is fair game. But because of the word and, it also has to be less than 8. What is that visually going to look like? How would you graph r is greater than or equal to 5? Pinpoint 5, open or closed? Ooh, I heard both now. It will be closed because of the equal to part. So Toby, my suggestion for you, I'm going to make sure you have a little table with you when you do the assignment today. Because so far that seems to be the only part you're tripping up, because your solving sounds great. So starting at 5, it is going to be closed. And I'm going to go which direction from 5? Careful. Remember, when you're thinking about graphing, you have to think about it with the variable in front. Greater than tells me to go right, because numbers greater than 5 are going to be over here. But I just can't go on forever, because if I do, will I break this rule here? What is this one telling me? So it's telling me I can only accept things that are left of 8. Am I including 8? No, because it doesn't have the equal to line. So I would have an open circle at 8, and you're telling me I would take everything to the left of it. What's the only range of values that works for both? Well, you're looking at the right area, 6 and 7, which happens to fall in between them. Now, 6 and 7 aren't the only values between 5 and 8. Because what about 5.1 or 5.37, 6.23? Yeah, there are infinitely many numbers between there, other than just the whole numbers that we see listed. But I can't go past 8. In fact, I'm not even including 8 because of this open circle. I can include 5, but I can't go past 5 because these numbers aren't greater than or equal to 5. These numbers aren't less than 8. Only this range works for both. Remember, and inequalities are very particular because the word and is very particular. Now, this is where I usually make 2 recommendations. 1, if you can get to this point with this amount of work, I will be thrilled. You will earn full credit. However, because most of us still don't know yet where we're going to go and what math we're going to end up needing at some point in our lives, I must show you what is considered the proper way of writing compound inequalities in this form. If you don't master it, it's not going to be the end of the world. You'll still be successful in Algebra 2. But another immediate reason why it's important is because the answer sheet on the assignment for today will have it written in the form I'm about to show you. So who remembers what we did at the very, very beginning? What was the first thing we did? So it's kind of like we slid them apart, right? And what was in the middle was kind of duplicated. Well, with and inequalities, when we reach the end, they really want to be slid back together. And the reason for that is 3r minus 7, particularly that r that was along for the ride on both of these, is the same r. We were just sharing it in the 2 situations. So what most mathematicians will ask you to do, and the way that it's written on the answer key for today, and inequalities really, really want to slide back together because that r is the same for both. So technically, the final solution would be that 5 is less than or equal to r, which we didn't dwell on too much because we can't graph from that. But then on the other side of that, I'm going to write that r is less than 8. Now, if you're having trouble saying where the heck those come from, watch this cool visual effect. This one was right here, right? And this one was right here. All I did, slide them back together. Now again, if you're still sitting here thinking, what just happened? If you can at least solve the 2 parts and find the graph that goes with it, I'm going to be happy. I'm only showing you this because the answer sheet's going to write it in that format. And I don't want you to get to the very end and think, oh, shoot, I'm wrong, just because it's not written in that exact form. Questions so far? So let's practice one more and inequality before we get to the easier cases, which are or inequalities. And you'll notice this one's a little bit more involved because now we have that same variable kind of scattered throughout. But let's stick with what we know. How do I know that this is compound? How do I know there's two inequalities hiding here? There's two signs. They're the same sign this time, which is okay. They are in two different locations, however, which means whatever is between them is going to have to be shared again. So before I can try solving this, I'm going to need to write them out separately to be able to do it efficiently. So my first one is going to be 2k minus 7 is less than or equal to 4k minus 1. Write my word and in there just as a reminder for later. And then the second one is going to start with that 4k minus 1 is less than or equal to 5 plus 2k. So two separate ones now. Setting up my little guidelines just so I can keep my work organized. And we go into solving mode yet again. So I'm going to start on the left inequality, that is. Any parentheses?
No.
No. Any like terms? No. Variable on both sides? Yes. So this one's a little bit more involved. So would you like to move the 2k or the 4k? Okay, how would you move the 2k? Subtract 2k from the 4k. So essentially from both sides. So on the left, 2k take away 2k is 0, leaving me with just a -7 here on the left-hand side. Less than or equal to 4k take away 2k, which is 2k. And the -1, because we didn't mess with it, slides on down as well. Now all that's left is to get that variable by itself. What would you like to move next? The -1, how are you going to move it? Yep. Add that 1 to both sides. -7 plus 1 is going to give me a -6. Less than or equal to 2k. The -1 plus 1 is 0, which goes away. What's last? We don't want to move all of 2k, just the 2 off of it. And how are you going to break that 2 off of it? Divide. I'm going to divide both sides by 2. -6 divided by 2 is going to give me a -3. Is less than or equal to the 2 divided by 2, which hides as a 1, leave me with just a k. Now, for my purposes, if we want to think about it graphically here in just a moment, I'm going to also consider it with the variable in front. And again, I didn't say it earlier, but these are the same two expressions. One is just flipped from the other. Same relationship. But I'll hold on to those and I'll shift over to the second one to run through a similar process. So I'll go a little faster on this one, just so you're not bored of doing the same steps over and over and over and over again. So there's no parentheses, no like terms. The variable, however, is on both sides yet again. So if I was solving this one, I would move the 2k by subtracting 2k from both sides. 4k take away 2k gives me 2k. The -1 drops. So does the less than or equal to sign. So does the 5. Of course, the 2k minus 2k is 0. So it's out of the picture. All that's left now is to get the variable by itself. So I'm going to move the -1 next by adding 1 to both sides. That removes it from the left-hand side, leaving me with just a 2k there. Less than or equal to comes down. 5 plus 1 gives me 6. And then last but not least, break that 2 away from the k. To do that, I'm going to divide it from from both sides. Simplifies to 1 on the left, leave me with k is less than or equal to 6 divided by 2, which is 3. Let me bring the number line into picture. So according to my two solutions, my two parts, all my answers are going to have to be both greater than or equal to -3. And that's according to this statement right here. But they also have to be less than, excuse me, greater than or equal to -3. Did I say negative the first time? I don't think I did. So greater than or equal to -3 and less than or equal to +3. What's that going to look like? Closed on both? Okay, so closed circle at -3, as well as the closed circle at +3. Where's my final shaded region going to be? In between them, because the first one that we solved said we wanted everything to the left of, to the right of -3. And the second one told me I wanted everything to the left of +3. And the only area that satisfies both, because and doesn't accept anything other than everything being true, the only region that it works for both is everything in between, which means anything that is shaded, including the endpoints, which are shaded in, any value that you could think of from -3 to 3 would be considered a solution. And that's more than just the whole numbers that are listed here. All the fractions and decimals in between also count as well. So, oh yeah, last but not least, considering the answer format that you're going to see on the worksheet for today, I'm going to slide the two back together, and that's going to give me -3 is less than or equal to k, which is less than or equal to +3. That concludes the and inequalities. So there's no way denying it. Yes, this is more work, but it is also a good chance to exercise the same skills we're practicing, the past couple days, which is good news because this is technically the last lesson of Unit 1, which seems very quick, does it not? So tomorrow we'll be reviewing yet again everything we've covered the first 3 days in preparation for a test on Monday, which always makes people panic the first time. But once you start to see the format of review and then you see the test itself, it's a little less scary. All right, last 2 examples. Switching gears here a little bit. Or inequalities are my personal favorite when it comes to compound inequalities. And the reason for that is they don't start together. You always see the word or. And at the very end, you don't have to do a fancy trick where you slide them back together. They're separate the whole way through. They're even separate on the graph when we get to that part. And we'll see that here in just a moment. So I'm going to start here on the left. Set up my little guidelines here. These appear to both be just 2 steps each. Notice the word or, that's great. That tells me exactly what I'm dealing with here. I'm going to start on the left. Any parentheses? Nope. Like terms? Nope. Variable on both sides? Nope. All that's left then is to get the variable by itself. So it looks like the R is on the left-hand side this time. What would you like to move? That 10. So it's a -10. I will use a +10 on both sides. 6R is going to drop down. Negative 10 plus 10 goes away. Greater than or equal to 44 plus 10, which gives me 54. What's left to move? 6. It's right beside it, so I do the opposite of multiplication, which is division. Divide both sides by 6. So R is left on the left-hand side. Greater than or equal to 54 divided by 6, which I believe is 7. No, it's not. It's 9. As soon as I heard it come out of my mouth, it's like, no, that's not right. Sometimes I don't know where my brain's at, which is why I'm glad I'm full of a room of people who are at least halfway paying attention. All right, we have half of our answer. Our solutions have to be greater than or equal to 9. Now I'm going to solve the second one. Very similar format, no parentheses, no like terms. The variable's not on both sides. So I'm really just going to work to get that variable by itself as well. It is also on the left-hand side. So I'm going to focus there and first subtract 10 from both sides, which removes it from the left, leaving me with 5R is less than negative 25. Take away 10, which is a negative 35. And then last but not least, I'm going to divide away the 5 from both sides, simplifying it on the left, which hides it, leave me with R is less than negative 7. Now, here's the exciting news. I don't need to worry about writing them in some really cool, intricate way where they slide together. Don't worry about any of that. All I need to do is write the word or between them. And that is my final solution for this compound inequality. And here's the reason why I really can't write them together. Let's think about this. Actually, let's see it visually. How would you graph R is greater than or equal to 9? Closed circle at 9, which, silly me, I put number lines that didn't even have it labeled because this little mark here represents 10. So I need to put a little hash mark between those. That's my 9. Okay, Toby, you said closed circle. Which way are you going to go from there? Oop, greater than or equal to the right. How are you going to do R is less than negative 7?
A little line above negative
In front. Technically, it would be to the right of it. So right there. So good. You're calling out my mistake there too. And what am I going to do with this negative 7? What do I need to put there? Not quite. It's actually going to be open because that one is not equal to. But Toby, you said to the left. What do you notice that these two graphs do not do? They don't touch. In fact, they started away from each other and they're going further away from each other the further out you go. I may be thinking, why is it so different than an and inequality? Well, let me ask you this. Can you think of a number that is both greater than or equal to 9 and less than negative 7? Probably not, because any number that is greater than or equal to 9, there's no way it's going to be less than negative 7. They aren't designed to meet, and that's okay because of the word or. I don't care whether the first one is true, meaning that it's somewhere over here, or the second one is true, which means maybe it's somewhere over here. So long as it's one of those two locations, we're happy. Or is very laid back. All right, one more, and then I will stop talking your ear off. Again, another or inequality. I see the word or in there. I'm happy about it. So I know that I don't have to do any fancy tricks or share anything or anything like that. So I'm going to set up my guidelines here. Start on the left. No parentheses. Any like terms? No. Variable on both sides?
Yes.
Yes. What would you like to move first? The minus 3K. So the opposite of that would be plus 3K. So it allows me to eliminate it on the left-hand side, leave me with just that positive 10. Bring down my my less than symbol. K plus 3K is going to give me a total of 4K. And the plus 6 falls on down. All that's left now is to get that K by itself. So we're focusing on the right-hand side, which is where it's located. What would you like to move next? 6. So I'm going to subtract the 6 from both sides. 10 minus 6 gives me 4. Is less than 4K. The 6 minus 6 is gone. And last but not least, divide both sides by 4. On the left, 4 divided by 4 is 1, which I don't want to hide because it's the only thing there. But on the right, 4 divided by 4 is also 1, but since there's a variable there, I'm going to hide that one instead. So I have 1 is less than K, which for our purposes, it's going to be a whole lot easier. So instead of leaving it as 1 is less than K, I'm going to flip it to say K is greater than 1. That's going to help me when I transfer to the graph down below in just a moment. Not quite done. We still have the second half to consider. For the sake of boredom, I'll go through it a little bit quicker. No parentheses, no like terms. The variable is on both sides. This one's a little bit sneaky because on the right, that is a negative 1K. So technically, the smaller of the two would be the negative 2K. So I'll add 2K to both sides. Negative 8 is going to fall down. Negative 2K plus 2K is gone. The greater than or equal to sign drops. So does the 10. Negative 1 plus 2 gives me positive 1, which I did this trick, I think, yesterday. I'm going to leave the 1 hidden because that's going to save me a step here in just a moment. Because all that's left to do is to get that variable by itself. And with that 1 hiding on the K, all I see that needs to move still is I need to subtract 10 from both sides. So negative 8 minus 10 gives me a negative 18 is greater than or equal to K. And then for my purposes, I would like that rewritten as well to where it says that K is less than or equal to negative 18. So we've come to the conclusion that our set of solutions either has to be greater than positive 1 or less than or equal to negative 18. And because it's the word or, we know that it's going to be 2 separate regions because there's no way to satisfy both. But that's okay because it's the word or. How are we going to graph K is greater than 1? Find 1, which is just to the right of 0. We have to put a little notch in there. Open. Not equal to is open. And shade which way? To the right. And what about k is less than or equal to -18? This one actually has a notch. It's just not labeled. Open or closed? Heard closed. And which way from there? To the left.
When you take a break, you can help us busy and I, if you have time. Whenever you take a break, no hurry.
All right. Now, one last thing to point out, and then I will get you guys your copies of the assignment for today. Notice that and inequalities and or inequalities kind of have their own look to them. And inequalities, when we got to the graphing portion, was typically a shaded region between two endpoints. Now, those endpoints could be open, they could be closed. That really just depends on the sign itself. Whereas the or inequalities had two endpoints as well, but instead of shading between them, we shaded outside of them, away from each other. That's going to be the typical pattern that you can expect to see, depending on whether you're graphing an and inequality or an or inequality.